Hello. In this video, I describe a new feature introduced in KStars version 3.7.0 onwards that will deliver a better experience to visual observers, that is, to anyone who uses their eyes at the eyepiece of an instrument to observe the night sky. The new feature called Views allows you to set KStars up to match the sky map view both in orientation and scale with the various instruments you would use to look at the night sky, such as your naked eye, your finder scope, and your telescope. Let me first illustrate how the feature works. Let us imagine that we are star hopping to the Triangulum galaxy. I have predefined three views for my three instruments: the naked eye view, which we are presently seeing, my finder scope view, and my telescope view. I can quickly cycle through them with the shift page up and shift page down key combinations. KStars will then alter the orientation and optionally the scale of the sky map to present the view as it would be seen through each of my instruments. First, in a typical use case, I would start by finding the star patterns using the naked eye view, which you are presently seeing. Then I would switch to the finder scope view so that I can do the find star hopping in my finder scope. Once I'm done using my finder scope, I can cycle into the telescope view so that I can identify the faint spiral arms and the patches of nebulosity that decorate this galaxy more easily by knowing their orientation in my eyepiece with respect to the core of the galaxy. So in this case, I know that NGC 604 will appear at 5 o'clock in my eyepiece. So it is a common belief that the view through a typical telescope is a 180-degree rotation of the view as seen with the naked eye, that is, an inverted view. Practically speaking, this is true when you're looking through a straight-through refractor without a diagonal, or when you're looking through a Dobsonian telescope that's pointing close to the horizon, or if the display rendering the sky map is mounted on the telescope tube. In actual use, a refractor is frequently endowed with an erecting prism, which flips the view up-down, resulting in a mirrored view. In a Dobsonian, where the eyepiece is on the side of the telescope, the user's head does not remain perpendicular to the telescope's tube when the telescope is pointed above the horizon. This introduces an additional angle between the inverted view produced by the telescope and the observer's sense of up and down directions. In KStars, this additional correction is called the Erect observer correction, and it depends on whether the telescope is designed for left-handed or right-handed operation. You can see by zooming out that the orientation of the sky is not inverted. It is at an angle. And this is to account for this particular correction. Not only that, the angle at which the eyepiece is placed also makes a difference. A lot of Dobsonians will actually place the eyepiece at a 45-degree angle from horizontal. The aim of the views feature is to account for all of these complications using a simplified user interface. Let me now recreate three views for a typical Dobsonian user to explain the setup process. To set up the views, we go into the View menu, go down to the Views submenu, and then go into the Edit Views option. This brings up a dialog where we can modify, create, or remove existing views. Let me remove the three views that I have defined to start from scratch. If no views have been set up by the user, KStars actually populates this list with a standard set of commonly used views. But we will now set up our desired views manually. We click on the New button to bring up the interface that is used to create a new view. Here, we will first name the view. I'm going to start by creating the naked eye view. The mounting type here selects the natural coordinate system to use. In most cases for visual observation, it should be left at altazimuth even if the telescope is mounted on an equatorial mount. This is because most equatorial mounted telescopes have a rotatable diagonal for easy viewing, and it is natural for the users to change that to the same convenient angle with respect to the ground, no matter where the telescope is pointing. In any case, for the naked eye view, it is clear that we will operate in horizontal coordinates, so I will leave it at altazimuth. Next comes the view type, which sets up the base view produced by the instrument. In the case of the naked eye, we see the sky in the correct orientation, so we will pick correct. Then there is no further correction from the eyepiece angle since we are just using our eyes. We can optionally ask KStars to set the zoom level to have a 60-degree field of view for our convenience, so we can see a wide region of the sky. Then we can hit OK to create the new view. Our new view is created. Next, we create the view for the finder scope. We will name it 9x50 finder and leave the mount type at altazimuth. Typical finder scopes are either straight through, that is inverting, or they are right angle correct image finder scopes, which feature a so-called Amici prism diagonal that fully corrects the view without any mirroring. For this example, let us assume that the finder scope is straight through, so we will pick inverted. Since the finder is viewed straight through, there is no viewing angle or eyepiece angle correction to be applied. A typical 9x50 finder scope has a 5-degree field of view, so we will ask KStars to set a 5-degree field of view. So we can click OK to create this new view. Now, we create the view for the telescope. We will assume that this is a typical mass market small Dobsonian like an 8-inch telescope from Orion or GSO. Most of these telescopes have a focuser placed so that the sky is on the observer's left side when they are looking through the telescope. This is what in KStars we would call a left-handed telescope, because the user would use their left hand to grab the aperture of the telescope to move the telescope. So we will also assume that this focuser is placed at a 45-degree angle from the horizontal, which is typical for these mass market telescopes. We will start by naming the view my Dobsonian. We leave the mount type at altazimuth. We set the base orientation, the view type, to inverted, since that's what Newtonian or refracting style telescopes do. But to account for the additional corrections that result from this being a Dobsonian with an eyepiece angle that changes with respect to the observer's head, what we described as the erect observer correction, we will adjust the eyepiece angle to match the telescope's construction. So since we are using a Dobsonian telescope, it's natural to use the image on the left for reference. The illustration on the left shows the view looking down the tube of a Dobsonian or a Newtonian telescope. Since the focuser will then lie on the right side in this sort of telescope that is left-handed, we will drag the eyepiece angle slider to set the orientation to 45 degrees, and the view looking down the Dobsonian's OTA should match this illustration that's on the left side of this image illustration view here. The silhouette of a person here shows on which side the observer is assumed to stand given this eyepiece orientation. We can then set the field of view, let's say, to 1 degree to match our finding eyepiece. Click OK to create the view. As a further illustration, let us create a view for a Schmidt-Cassegrain telescope. Visual observers using these telescopes typically will use an erecting prism diagonal to ease observation. We will name our new view as my SET, leave the mounting type at altazimuth, and select mirrored to produce a mirrored view matching the erecting prism. We will now assume that the user rotates the diagonal to the same orientation every time for ease of observation. The illustration here on the right, which is more amenable to use with a Schmidt-Cassegrain, shows the back of a Cassegrain telescope. Okay, so we will now imagine this time that the observer is left-handed and likes to have the focus knob, which is on the back panel of the Cassegrain telescope, accessible with their left hand. Therefore, they will rotate the eyepiece to the right in this preview. Let us say that the observer keeps a consistent 45-degree angle, so we will adjust the slider to read minus 45 degrees. The exact value is not important. It's hard to adjust the exact value. You can use the left and right keys to get the exact value, but it's not so important. We can once again set the field of view to, let's say, a 1 degree for a finder eyepiece. Then we can click OK to create the new view. Now we can see what it looks like to cycle between these 4 views. This is the Schmidt-Cassegrain view, and you will see that it is mirrored with respect to the telescope view. The views feature provides a rapid way of switching a host of settings, but each of these settings is also individually accessible. For example, we can manually adjust the rotation of the sky map by holding down the shift key and dragging the mouse cursor with the left mouse button depressed. This shows you the north. N stands for north, Z stands for zenith, and E stands for east. It shows you the orientation that you're setting with respect to each of these cardinal directions. Similarly, you can manually mirror the sky map, toggle the mirroring of the sky map by going into the view menu and picking the mirrored view option or hitting the Control Shift M key combination. You can also use the sky map orientation submenu in the view menu to enable the Erect observer correction or pick between a few predefined orientations. You can also use the space key or this particular option to switch between equatorial coordinates and horizontal coordinates, as has been available in KStars for almost over a decade. We hope that the views feature will help significantly ease your visual observing by pre-scaling and orienting the star patterns to match what you would see through your instrument, making it a lot easier to identify the star patterns for star hopping or to find out where a go-to mount hit when it did not hit exactly on the target. Then knowing the correct clock position where the object lies should make it substantially easier to home in on a faint galaxy with your eyepiece. Please leave feedback on the Indie forums or the Facebook group. KStars is free and open source software, and you can contribute to it as well if you're familiar with C++. Thank you for your attention and interest in KStars. I felt that it is useful to dig further into what exactly the Erect observer correction does so that its use can be fully understood and appreciated by visual observers. Pictured here is a caricature of a Dobsonian telescope. The eyepiece is portrayed on the left end of the telescope, which is where the light enters from. The arrow displayed in the eyepiece indicates the direction of the zenith, the upward direction in the night sky, which has been inverted by the telescope, that is, rotated by 180 degrees. Now, as we move this telescope higher up in altitude, the frame in which the inversion occurs rotates with the telescope. So the arrow in this case still shows the direction of the zenith as imaged by the telescope in the eyepiece. However, you will notice that an observer standing and looking through the eyepiece would see that this arrow has deviated from the downward direction by an angle equal to the altitude of the telescope. Therefore, an additional correction is necessary to match the view through the eyepiece as is experienced by the observer. This correction will depend on whether the telescope is designed for left-handed use, as is here. The left hand grabs onto the aperture of the telescope and is capable of moving it, or whether it is designed for right-handed use, in which case the correction would be in the opposite sense and therefore would come with an opposing sign.